Hi, this is a video by Mr. Holmberg at Corvallis Middle School in 5th grade. I'm going to teach you how to use a visual model to learn how to multiply fractions and a whole number. I'm just making a key basically for a homework assignment this morning and thought that I would just show how it is that I'll be teaching this in class. The purpose of this video is to help parents understand and students understand why an algorithm, like a shortcut for multiplying fractions, works using a visual model. So I have several examples that are already done here on the key. And starting off, you've got 8/10 times 6. So there's your whole number and there's your fraction. And this, of course, is called an improper fraction because the number on the top is larger than the number on the bottom. And next to it, we've got the model. And I've shown an answer and a reduced answer and a simplified final answer. I've really been emphasizing to the students throughout math that being precise in math is important, so hopefully their work should look as neat as mine does. On this worksheet, on the answer key, you're going to see that it's shaded. And I am recommending to students that they not shade because I think it makes it kind of messy. So instead, what I would want them to be doing is counting. And for the sake of it here, I'll just say that counting would look like they're using dots like this to count the number of unit fractions within each whole that are shaded rather than shading. But I might not shade I might not put a dot in every diagram on this page because this page has already been made for me. But students should be in class using dots like this as they count through it. So now that I've made dots on just about most of them, and you can trust what's going on there, I'll show how to do some of these. Again, the purpose is to help students understand that they can do this and then go from that step to this step without needing a diagram, a visual model. But it's good to use the visual model as a means of trusting that, oh, this shortcut, this algorithm works, so therefore I will use it, I know how it works. In this case here, what students are doing is they're going to simply start by practicing the algorithm. You multiply the whole number by the numerator, and that makes 48, and you put it over the denominator in each case of these. So I'll show that again. 3 times 4 would make 12, and 5 is the denominator. 3 times 1 is 3, and 5 is the denominator. 6 times 4 is 24, and 5 is the denominator. So that's the procedure. And then they're going to be converting that that improper fraction to a mixed numeral and reducing it after they get done practicing the visual model. Some students might understand this right away. Other students may really benefit from seeing how it works. So if I have 48/10 and this circle is divided into 10 equal pieces, those are all tenths, and if I have all of them shaded, that's 10/10. So 2 of them is 20/10, 30/10, 40/10, and then because I had 48/10, I'm going to count out 48 of the remaining tenths in this. You'll see I've drawn a little bar underneath each one of these, and that is a means of counting the whole fractions, the whole numbers, that are represented by these fractions. So this is 10/10, and this would be another 10/10, another 10/10, another 10/10, and those would be 40/10 or 4. The remaining then is 8/10, and so I've got 8/10, and I reduce that. In this case, you can just cut them in half. 8 divided by 2 is 4, and 10 divided by 2 is 5, so 4 and 4/5. This one here is 12/5, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, and then 1, 2 makes my 12. So there's 2 wholes and 2/5. And this one just kind of small. We have 3/5, so I just put a 3 above it, which is a little misleading. Students might think for a second it's 3 wholes or something, but again, it's 3 and these are the fifths, so really it's showing 3/5. And there's nothing to change on the end of this one. 24/5, so I'm going to count 5/5, 10, 15, 20, 1, 2, 3, 4, 24. My wholes are 1, 2, 3, 4, there's 4, and I have 4/5 remaining, 4/5. Okay, so I'll do one now here all the way through so you can see it. 7 times 2 would be 14, and in this case it's 14/4. It's good that students practice saying